Welcome, Dan. How you doing?
Good.
All right, we got some toys in front of us, I see. What we wanted to do today is we wanted to go over the history of the design, engineering, and manufacturing of the Beast Gear mobile hang-on stand. There's a lot of features on the tube, the platform, the antler bracket, the sticks and how they attach to the stand himself, as well as just the history on how this platform and the specific design of it started. So I think, Dan, to start out with, what got the wheels turning in your R&D machinist mind to start looking at this type of platform and stand?
Well, years ago, looking at cast stands, I looked at why they made them cast, and it was to be rigid, to take the noise out, stuff like that. And I noticed that you had to make cast material bulky because it's fragile.
Right.
It doesn't have the grain. And being an R&D machinist and working on new products and stuff, I understand the materials really well. And an extruded material was something that wasn't being used for platforms. So I decided that I wanted to try making a stand out of an extruded material from one sheet. And the reason being is that you can make it out of the same aluminum that you make a cast platform out of, but you can make it much smaller, make the rungs smaller, and have way more strength. Therefore, you can make it lighter. So you could take each one of these rungs and make them really thin because they're not going to snap. They're going to bend and give and come back. And I thought that was something that the whole hunting industry was missing in tree stands. And from there, we started developing prototypes of this stand.
Yeah, and there's also the advantage of, like you said, making it out of the same material that some very popular stands are being made out of now, but the strength portion of it, the solid aluminum billet being much stronger with using a lot less material, which
Right.
was a key differentiating factor.
A lot of other companies had used like jig plate, aluminum plate, which is really cast, to water jet and to machine prototype stands.
Right.
But they really didn't understand the grain stuff like I understood. So I saw how there was an opportunity here to make a stand out of machining it or water jetting it.
Yeah. So to start out with, when you started designing how this might look, I mean, maybe you could walk people through sort of the process of and the type of machine you started utilizing to make the initial prototype platform out of.
Well, the first thing I did was make a design that I felt had maximum strength and just build one and try it. And then I think we were both a little shocked at how light it was.
Right.
And how well it worked. And then from there we said we overkilled it. I mean, it was way lighter than a regular stand, but it was really rigid and strong.
Right.
So from there we went to the engineering room and we started using models and seeing how much strength we could put in, or how much material we could remove from different areas, how we could move different rungs and stuff, and make it as light as possible. And we spent quite a bit of time doing that. I mean, we ate up a lot of time and a lot of money in developing the lightest version of how we could expand the metal this size. And you could make it bigger, but it would flex really bad and it would not pass testing.
Right.
So we took it to the limit on what we could do to make it as light as possible and move the rungs around and still, you know, have a shape that fit our buttons for our tube so we get it as flat as possible, all of that stuff. And then too, at the same time, we're looking for the perfect angle and the perfect bite to a tree so that it would lock and cam lock into a tree. And we went through several versions of that too, and eventually came up with this version that cam locks really well.
Yeah. And a lot of what Dan's talking about, I mean, you have really three main attachment points that your stand is attaching to your tube, which then attaches to your seat, but you've got where your cables attach up front, and you've got where the main seat post attaches in back. So the width of these different rungs at those specific spots, along with the distance of those rungs from the additional material that's on this back V, those are all important in how much load the stand can actually take, especially under a lock scenario. Because there is actually quite a bit of pressure that's applied to the whole stand apparatus itself, this housing part, when you are locking it on a tree. And then obviously the force of, with someone standing on it and individuals out on the tail end of it, since a billet with less material is going to allow for a lighter weight platform, you're also going to get some flex because of the design of the stand and the light weight. So you have to account for that in your cable positions and also the amount of material that's in your cable attachment points.
Right. I mean, we saw a lot of the competitors racing out with stuff, and they had it built wrong here. And from the engineering background, I really felt bad because I knew it was going to break. But you say something, and then you're the bad guy. But then we start seeing them break on the competitors. We went through extreme testing because I literally care about the people who follow me. I don't want to put stuff out there that's going to put people in danger. So we really overkilled this. I mean, this could have been out literally years ago, but I just wanted to make sure everything was perfect. And maybe I'm a little bit of a perfectionist there, and I think you got a little of that in you too. But I mean, even right down to the color of the coating we got on here. This blends into everything perfect. I mean, we went through greens, and we went through browns, and we went through everything. And this blends in with the background the most from early season to late season.
Right.
Throughout the whole season. And anodizing ain't cheap, but it's a really good, hard coating that protects it from scratches and blends in really well. And then we could alter the color to where we wanted it.
Yeah, yeah. So once you got the base platform design down and you tweaked it to the point where you felt it was in good shape, what process did you take it to after that? I mean, what did you start doing in the field with your first initial prototype?
Well, I beat the hell out of it. I literally tried to horse it as much as possible, but it was realistic hunting. My hunting is pretty extreme in the first place. I'm hunting in swamps where there's one tree. I mean, it's crooked, it's bent up, it's nasty, and that's what I'm used to hunting. I'm used to hunting really extreme things, and I wanted to make sure it would work in any tree, would work in any scenario, and I also wanted to make sure it would take the extremes, because I mean, you can get to a tree where you put all your weight into this rung because of the way you set it up. You can, and I wanted to make sure nothing gave. And I mean, we'd take the stands back after we put them through a lot of force and check them. Yep. And I literally took these things out and put them in trees where I normally wouldn't hunt, and really put some pressure on them, jumped on the ends, and tried some things with them, and really put them through hell. And this particular model held up to everything.
Yeah, and the process by doing that, you take it out, you disassemble the stand, you take the stand as is, we meet with our engineering team, and then you start measuring the varying tolerances, or measure if there's any distance that changed in your gap of your ears, or any of the leaves in the position of the stand after going through field testing. Why don't you talk about, too, what else we did inside the shop itself, as far as a testing procedure for the platform itself?
So, I wanted to make sure it would withstand the weights of anybody that's going to use it. So I tested this following the ATSM testing in my facility, which I do testing I'm in a full prototype shop.
Right.
So I do that work. And I tested it to a 300-pound rating, and it never failed. I took it to the limits and a little beyond the 300-pound rating, and it worked perfectly. It took a while to get to there because we tried making it a little lighter, and then it didn't make it. And we made it right to where it passed that 300-pound rating, which we did with static load. And we put it on and off and on and off. But I literally put weights in here at different positions. And if you remember, we had, what was this, solid steel weights stacked 7 feet tall, and tested it the same way they do in outside testing. And that was pretty critical to be able to do that in shop, because outside testing doesn't allow you to test different limits
Fail
and
and
stuff.
retest.
Right. So we were able to, test it to see where it failed and such. And by doing so, we were able to tweak it to get the lightest model we could get, instead of some of the other companies that don't have that type of facility around, either overkill it or to guess.
Right, right. So that process allowed us to work with the engineering team to look at the designs. Dan would continue to machine and tweak the actual prototype platform, to go back with engineering and say, okay, this is how it field tested, this is how it tested static load in the shop, and then we could begin to modify the designs. I mean, a lot of it was around this back-end component and how this engages the tree.
That's where a lot of the stress is,
Yep, and then up front where our rungs are and how these rungs lay out to allow for force coming down.
Yeah, even in the exact position and where the cables go and the angle of the cables makes a huge difference in the strength.
Yep.
What else was interesting about that is we weren't satisfied with me just testing it. I really wanted an outside firm to look at it too.
Right.
And we wanted to get this officially tested by another company. And I think that's pretty important for a company to lower their pride a little bit and have outside testing done, to make sure that they're looking at it the way they should.
Yeah, so we decided to to send our stand and sticks, but we contracted with an outside firm to test against all the ASTM standards that are developed for tree stands and climbing sticks that are out there. So our decision was to have it tested at a 275-pound weight rating, and what they do is they really do two different types of tests. They do a static load test and they do a dynamic load test. The static load test is tested at the 275-pound weight, and then they go ×2, so they bring it up to 200%. So at 550 pounds, they test it there, and then at the dynamic rating, they take your standard weight rating that you prescribe. So for us, it was 275 pounds, and they take that through a 10,000 cycle dynamic test where they're simulating that weight being applied to the stand over those cycles.
We had some long discussions about what to rate it at. Whether it would be 275 or 300. And the standard is pretty much 300. Everybody rates at 300.
Right.
We've got a smaller platform, and I worry about having a big guy on there. Not that the stand's going to fail, but they could fall out or something. And I just felt like most people, over 275 are probably going to buy a bigger stand and stuff, and I just wanted it to be safe for everybody. It passed in our facility at 300, and it was interesting because even the facility guy mentioned that the outside testing company mentioned that, well, it looks like it would have passed at 300. Why didn't you do that? And then I was surprised. We got a lot of feedback from our customers that they would have rather had 300. Yeah. But I think 275 is a good rating for it. I just, smaller platform, big guys.
Yeah.
I don't want somebody falling out of it or getting hurt. And for me, it's really about safety and about, that's more important than making a little extra money by selling it to everybody.
Yeah, yeah. Yeah, so that's really how we landed on that design and the process that it went through to get there. The first prototype of this, I think it might have, how many man hours do you think you had into machining and moving this thing through?
Oh yeah, there's a lot of versions of this stand.
Yeah.
I really like the first version, so I made this into a rack, an Antler rack. but it just didn't cam lock the way we wanted it to and stuff, and we had to
Right, we had to redesign.
redesign it,
Yeah.
But there was a lot of man hours to a lot of stands, and it just kept getting better and better and better. And every time we were thinking about releasing, we'd come up with some way to make it even better, and
Yeah,
we'd tweak. Like I said, a little bit of perfectionist.
right,
You know, literally, I mean, if I made the stand the very best version I had, I really liked it, but it would have been a $1,500 stand.
yeah,
You know, so we also had to work on what was the best version, cost effectiveness, what price we could put on it. Because I really want people to be able to afford it and be able to hunt out of it. I don't want to price it out where the average guy can't hunt.
yeah,
But it is a once in a lifetime purchase, so I wanted it to be a really great stand, but I had to back off on some of the things I wanted just to make it more cost effective and so it would actually get out there.
yep, yep, yeah. So, moving on from the platform, the next fundamental piece that's part of this stand is actually the seat post or the tube. So maybe we want to talk about this a little. This is a extruded 1.25" aluminum tube. Want us to talk about the factors of the aluminum tube itself and why you chose to go with this type of design.
Well, tubing is the strongest type of shape you can have. It's got 4 walls. A solid material, you could make it solid, 1-inch piece, and I don't think it would be as strong as this tube, it would bend. But when you take and put 4 walls on it, you got 4 walls fighting each other that make it stronger, which is why some of the other companies are using tubing. You know, solid pieces aren't real well, I mean, they'll bend. You have to make them way more beefy. You have to make them strong, you have to have more weight there.
Add extra material, yeah.
Right. So the tubing was, we could have it as light as possible and as strong as possible with this type of shape, using an extruded material. And we could still do weight removal where we could with the holes. And we got the holes round so that they're stronger. And then we don't put holes where we need the strength, where our computer models show us we need the strength. The sidewalls here needed to be strong because the force on this is into the tree right here.
Yep.
So we, again, a lot like our sticks, we tweaked this design and tweaked this design in computer models until we got it to where it was, strong enough to withstand, what we needed. So what's interesting is then when we field tested it, sometimes that wasn't, the computer models didn't match up and we had to go back to the drawing board a little bit because we got some bending and such. But then we beefed it up where it needed to be and got it again to right to the point where you can have it as light as possible, it still ain't gonna bend on the guy.
Yeah. Well, and I think if we go back to the original, we talked about this a little bit with the sticks, is the whole purpose of this. Being an avid mobile hunter and wanting, out on the market, there was tree stands that were around, let's just call it, depending on some of the ones that were out there, around 8 pounds to 14 pounds. Really the most popular one, the lightest one, was around 12 pounds, 12 to 14 pounds. So with this platform, the goal was, could you cut that in half? Could you significantly reduce it?
Mm-hmm.
And the other thing with that is that hunting this style, you're going up and down a tree, setting up, taking down on each hunt, sometimes multiple times a day. If you're moving around during the rut or the pre-rut, if you're traveling in and out of going out of state. So how could we make the lightest and safest platform for someone who wants to be really mobile and shave that extra weight off for them? And as Dan mentioned, in choosing the tube and the placement of the holes and the position of the slide cutouts and all the areas in here, there's a lot that goes into, well, how is that sitting in position with the platform? What's the distance between the tube and the ends of your engagement brackets? What's the distance between the tube and the tree? All that factors into how this stand is going to set.
Mm-hmm.
on a,
There's a lot that goes into just the angle of the cables.
yeah,
You change it a little bit, and all of a sudden you start having issues.
right. Because under a lot of scenarios, if you don't, we've all gone to those spots where you have better than average trees. You get nicer, straighter trees, you can set your stand up, you can pitch it at a certain angle. For the most part, it's working out really well. Getting into some of these nicher areas, or if you're on the move and you gotta go and get into that little tree or that crooked tree or a tree that's not quite perfect.
Or if you're getting to the point where you're smart enough to know that whitetails live on the edge, you're in some pretty crappy trees when you're on the edge.
Right. And so Dan was really focused on, again, that human purpose. I want to create something that's light, and I can get into these areas that it was more difficult to get into with what was available out there on the market.
I'm out there actually, and you're out there actually hunting mobile, hunting public land, running to other states, hunting different properties all the time, and moving into new scenarios constantly, and new types of trees. I mean, there's times when I've pulled 3 bushes together and used them as a tree to get a stand into, so it was strong enough to hold me up. I don't think most of your manufacturers are doing things like that, but I do think the people watching this video are.
Yeah.
They are hunting like that. So I think being on that same wavelength, hunting like they do, helps us develop the proper tree stand for that type of hunting.
And I think it's important, to stress the point that there's a combination of purpose, which drove the design, internal testing, engineering, and then external testing, which really lands this ultimate design and how this turned out where it was at. So there's a combination of many people, both internally and externally, that gets you to this place. And I think that's why, it is a differentiating factor versus what else is out there on the marketplace.
Right.
And the thing about Dan's mindset and how we look at, the stand and the other products that we make, going to continue to innovate. There's going to, we're going to continue to develop products in this manner using the same process of innovation with the prototyping, the internal testing, the use of engineering, and external testing to get these products to where we need them to be. And that's really producing a product for you guys as the consumer and other hunters that want to get out there and do this stuff so they can enjoy their hunt, they can be safe. All right, so moving on from the tube, one feature of the tube here is, I'm sure everyone is familiar with this, it's on a lot of different tree stands, but this is the slide cable area. I don't know if you want to talk a little bit about your design or how you made these knobs specifically for that.
Well, what's interesting about our knobs is almost all companies, whether they're American made or not, are buying Chinese knobs that are molded. And they're ABS plastic, they break easy, they're not strong, and I just didn't like them. You didn't like them. And we decided to use a very high grade plastic that's almost as strong as aluminum and machine them on a solid bar stock. And these are actually manufactured to perfectly fit the nuts and bolts. And at some point we may mold our own, but we're going to use the designs that we made, and we're going to use a stronger plastic. I don't like ABS plastic. The stuff's soft, malleable. It bends, it breaks down over time. And we use that same plastic in our buttons,
Yep.
in our plate for a stop for our seat, so that it's strong and lasts a long time. And that way we got the perfect distance from our tubes and stuff. I mean, most knobs that you purchase in quantity for a company like this are made for multi-uses.
Right.
So we're literally able to take our stand and tweak. So we can put our stuff together and say, what do you think of this fit? Do you got enough room for your fingers? We go through the room and the different guys test it and try it, and then we test it in field, see if it gets in the way of anything or whatever. It's not just buying a box of knobs and putting them on a stand.
Yeah.
We literally tweaked everything we have on this tree stand to make it perfect.
Yeah. And that's getting back to some of the tube design too, you know, there's specifics around the distance that the antler bracket sits from the top of the tube. That engagement and how that engaged the tree and the distance between that and the base of the stand is also gonna impact how you're cam locking. The distance between the antler bracket and where the button is impacts how you cam lock and hang against the tree. So we bring up these small details because that's the kind of thought process that was gone through in deciding how this seat post and how this tube should lay out, and ultimately allowing for the best possible performance when you're trying to hang it on those trees, or you're in on a mobile setup and you're trying to hang it in a new area that possibly you've never been in before. So Dan, why don't we switch over and talk a little bit about your antler bracket design here and how you really came to design this and what you were looking for in your design.
So I wanted to be able to fit on any tree from this big around, you know, to whatever size. And on a computer model, I tried to figure out the points as best I could. And then we went and checked them on different diameters and ultimately went out and used these in the field on trees. And we needed two set back like this and two up like this so it could grab the different smaller diameters really well. But this extra one back in here grabs onto angled trees up to 10 degrees. So then we can get on a tree that's on an angle.
Right.
And put the stand up straight. And again, we tweaked this design a lot. We made narrow points so that they dig in good, so they bite in, so when you're on an angled tree, it doesn't all of a sudden pop out on you like some other stands. So I think that this design has really came a long way and works really well. And I love the fact that I was able to make it look like a set of antlers.
Yeah, yeah. And as Dan mentioned, you know, the key factor there is a lot of tree stands that you'll see, they'll have another Y-shaped type bracket that a lot of times mirrors, you know, the classic Y shape that you might see at the base of a stand as well. The real advantage to having a more aggressive bracket that again has these points coming out at an angle at the end is it does allow you to hit that tree that's offset like this. Because if the tree is straight up and down, obviously you can engage onto that tree in the center post, but the moment that it becomes offset, you don't want to set up your stand like this because it'll be at a canter and you'll have to stand at that canter. So this bracket allows you to engage at that offset tree while still maintaining your seat post being up and down and vertical, so your platform lays flat. So the way that enables that engagement of that offset tree is a really important
What's
feature.
important about that too is when you take that angled piece that pivots, that V you're talking about that pivots on the tree stand, it's pivoting because it's got a looser fit with a washer in between to slide.
Right.
Now you got something that's going to loosen up. You got something that's going to break. You got something that's going to crack. You got something that's going to squeak. That's rigid.
Right.
It's not making noise. It's not breaking. It's not loosening up over time.
Yeah, and this is specifically designed to be slotted to match the tolerances of the tube that it's going on. And again, it's fixed in there through the tube with a grade 8 bolt, but that slotting allows for that locking, very similar to what we talked about with the designs that are used on the sticks as well.
And we even put a nice anodized coat on that too.
Yeah.
Rather than bare aluminum or painted or.
Yeah, these are all anodized black, and this is in a brushed titanium gray finish. Another thing to note, one of the smaller details, Dan mentioned this again about where we use Delron. So we mentioned that Delron is used on our bumper plate for the seat itself, which will handle where the adjustment knob actually hits. There's also Delron washers used in all the major attachment points
Yeah, not plastic, Delron.
Yeah, so
There's
it's,
a big difference because the plastic will wear, crack, and squeak.
right. So these Delron washers are used at the seat attachment points, they're used at the base of the stand attachment points, and they're used at the metal-on-metal contact on the outside rungs of the stands where the cables are. Now, they're used in combination with a very thin nylon washer up front here. So we have a combination of both nylon and Delron in the front to allow for that mobility.
And every one of those parts is being manufactured right here in the USA. So the seat to platform height is important too. So we looked at people's heights and average heights. And you can't hit it perfect for everybody, but you can hit it perfect for the average person.
Right.
And you want a seat at the height of, from the platform to when you sit down, your legs are straight. You have a perfect 90, right? So now, what you don't want is you don't want to tilt up like this if it's going to pinch your knees. I mean, if your legs are going up, you can put it up. But you don't want to pinch your legs right here, because that's what makes people's legs go numb. They don't even know why, but that's why you're uncomfortable in certain stands. It's because of the pitch and because of the height.
Right.
So in a lot of cases, you might even take this thing and pitch it down a little bit,
Yeah.
just so that this is not pinching the front of your legs. You won't feel it, but what'll happen is your legs will go numb. It'll cut off your sciatic nerve.
Yep.
So this is important, and this height is important too.
Yeah,
on stands.
Yeah, it's a 20-inch seat height, and then as you've seen with other stands that are out there in the industry, but this has plenty of adjustment, as Dan mentioned, to adjust this up and down, and that works in combination with your cable slide. So depending on the pitch of your tree or the angle of your tree that's moving forwards and backwards, adjusting this cable slide as well as the pitch of your seat will allow you to get a nice comfortable set for both standing and sitting. Now, I don't know, Dan, if you want to talk a little bit about really what the thought process was behind the seat itself, the design or the shape of it, or the overall size that you landed on. But what really were you looking for with the seat itself?
Now, if it was just for me, I'd have a seat about like this, and I would have no cushion.
Yeah, and actually,
But I'm not your average person.
yeah, the prototype was much more streamlined and smaller.
Yeah, it's because I
coming in
built
like
it for
this.
me.
Yep.
But I wanted it to be comfortable, and a lot of the feedback I'm getting from people is that they're not comfortable on seats. So I made this a size that you could fit your whole butt on it, and still wanted to keep it light, ergonomic kind of thing. And from there, we came up with that shape. Would fit most people.
Yeah.
Perfect.
And the seat goes through a very similar testing process. So the stress points mainly around this area that you see here and how that attaches to the seat post is under very similar stresses to what you're getting at the back of the stand. Not to the extreme level that you're getting back here, but there's similar stress points that happen here. So a lot of the internal testing and the engineering design focused on these areas, and then how much material could be shaved off of each rung out here while still maintaining that strength, but then reducing the weight.
Right, there's a whole different testing process that goes into a seat than a platform, because a seat isn't meant to stand on,
Right.
or to have your life depend on. So it's not as rigid as the stand, but it's time and a half, I think is what it was. Up to, like, if you want to rate it for 300, you'd take that up to 450 pounds.
Right.
With static load and then load after load after load. And again, we tested that in the facility up to 300 pounds for a rating.
Yep.
And it went over with flying colors. And we had it tested to 275 at ASTM.
Yep. All right, Dan, what do you got there?
So one of my main goals was to have the sticks attached to the stand and be real compact. So I made it so that the 20-inch stick nestles into that stand really well, where it just overhangs just slightly, and fits right in and locks in, and did it with one attachment threaded rod that's covered with a plastic material so it doesn't make noise, and real compact, and locks in there so solid it doesn't make noise or anything, and packs right through the brush.
And part of the reason when you did that is we wanted to maintain, it was really important to have a vertical stacking orientation. Part of that was how you could easily take the sticks off when you're in that real close scenario. So it was coming up with a way where we can maintain the vertical stacking and then keep a streamlined system for attaching to the stand.
Once again, it doesn't matter what order you have them in or anything like that, they all stack the same to each other. Where some other companies have stuff where you have to stack left, right, or they stagger out as you
Yep.
stack up.
Yep. So why don't we take a look a little more closely what we're talking about. We have the attachment point right here, which is brushed up against the antler bracket.
And that's important because that antler bracket locks them in flat, secure, so that gets your locking point.
Yep, exactly. So the stick itself is going to be able to come into that position and slide up onto that attachment point when they're stacked. And now we'll take a little look at more closely the threaded rod itself and how it works when you have a section of sticks stacked up. All right, threaded rod itself is a 5/16 threaded rod. It's coated with a rubberized shrink wrap on it to reduce noise as you're feeding the rod through the weight reduction holes of the sticks, either the 24-inch or the 20-inch mini sticks. On the top of the knob itself, there's a matching chamfer. This will match the chamfer that's on your mini sticks and your standard sticks in the hole placement where it is. So actually when this slides into that hole itself, that chamfer catches really nice and creates a nice locking surface when you're tightening these down. Again, as you're traveling from your truck to your setup or from your setup and back, this allows for a really secure attachment point and no movement of the sticks while on the stand. And again, that was really the goal here, is how do I make an attachment point to the stand that's going to be rock solid for walking through thick stuff, and it's going to give no sound or movement on the way to your setup. So the threaded rod itself, there's an attachment point right on the tube where the threaded rod is able to go in and screw in. These attachment rods are going to be varying lengths depending on the number of sticks you have. If you have 2, 3, 4, 5, 6 sticks, these can come in varying lengths so that you can attach your sticks to the stand itself. So in the field, you'll be able to secure them down nice and tight right up against the tree stand bracket, and then use this to unscrew it to take your sticks off of the stand. Again, the reason why we went with a fixed attachment point like this and a threaded rod, it enables a really strong, secure attachment and no movement. The sticks itself, for me, I prefer to have my straps wrapped, and then I'll take one strap itself and wrap it around my sticks, which allows them to be nice and secure. And then with that, I can take it and slide it right up against the antler bracket to prepare it so I can attach it using the threaded rod. And then I'll just drop the threaded rod right in. It'll lock in, and I can start securing them down. For you guys that like to store your backpacks and extra jackets, this provides a nice little storage platform where you can load that stuff up as you're carrying more gear into the field. If you've got camera bags like some of us do, you can set that camera bag right here, and it provides a nice secure platform for that. All right, well, that concludes all the information we have about the stand that's coming out. And if you guys have any questions, don't hesitate to go on the forums, ask questions of Dan or myself. You can also go to huntingbeastgear.com, and you can email us at info@huntingbeastgear.com, and we'll be happy to answer your questions. But good luck with the rest of your season, and hunt like a beast.